in all of you. Excellent. Kerala. Unacademy. Welcome to Unacademy classes. Unacademy offers YouTube classes to crack EAMCET 20, 21 and 22. Myself, Kerala, of educator in Unacademy. Today, I am going to explain electrolysis products and the numericals on electrolysis products. Picture 1. Okay. First, I will upload a slide that is electrolysis products. Okay, first one. The process of electrolysis using active metal electrodes. The weight of a cathode and a cathode increases or decreases. Okay, so it is harder type of electrolysis. In third type of electrolysis, weight of anode gradually decreases and the weight of cathode gradually decreases. Weight of anode gradually decreases and the weight of cathode gradually decreases. Right answer is weight of cathode increases and the weight of anode decreases. So right option is the first option. Okay. And next question. And next question. So already completed this last class. I will explain Faraday Laws. And the numericals based on Faraday Laws. What is the significance of Faraday laws. What is the significance of Faraday laws? Faraday laws give quantitative relation between weight of substance, deposited or dissolved or liberated at a particular electrode. Okay. Particular electrode and quantity of current involved in electrolysis process. That is the significance of Faraday laws. So what is the significance of Faraday laws? Faraday laws give quantitative relation between weight of substance deposited or dissolved or liberated at a particular electrode and a quantity of current involved in process. Quantity of current involved in electrolysis process. Okay. Generally, one Faraday current is equal to 96,500 coulombs, or Faraday current is equal to charge of 1 mole of electrons. Charge of 1 mole of electrons. 1 Faraday current deposits equivalent weight of the substance at a respective electrodes, and 1 Faraday current liberates equivalent volume of the gas at a respective electrodes. Okay, and equivalent weight of an element is equal to gram atomic weight by valence. The formula to calculate equivalent weight of elements. What is equivalent volume? Volume occupied by equivalent weight of a gas at STP is called equivalent volume. If you are familiar with these terms, we can easily calculate numericals based on Faraday laws. Okay, right. Suppose consider sodium ion to discharge or to reduce Na plus ion. One electron is required. By gaining one electron, it is reduced to sodium. To reduce one sodium ion, how many electrons are required? One electron. And deposits one sodium atom. To reduce 1 mole of sodium ions, 1 mole of electrons are required. And deposits 1 mole of sodium at a cathode. So to reduce 1 mole of sodium ions, how many moles of electrons are required? 1 mole of electrons. What is the charge of 1 mole of electrons? 1 farad. 1 Faraday current deposits 1 mole of sodium. What is the weight of 1 mole of sodium? It's a gram atomic weight, 23 grams. So 1 Faraday current deposits 23 grams of sodium. If we use 2 Faraday's current, how much amount of sodium will be deposited? That is equal to 46 grams. Okay, if we use only half Faraday current, how much amount of sodium would deposit? 1 Faraday deposits 20. Half Faraday deposits 11.5 grams of sodium. Therefore, what is the relation between quantity of current and weight? Both are directly proportional to each other. As the quantity of current involved in the process increases, weight of the substance deposited at a cathode also increases. As the quantity of current decreases, weight of substance deposited at a respective electrode also decreases. Therefore, what is the relation between quantity of current and weight of substance? Both are directly proportional to each other. That is called as first law of thermodynamics. That is called as first law of Faraday. What is the first law of Faraday? The amount of substance. The amount of substance deposited. The amount of substance deposited or dissolved or liberated at a particular electrode. At a particular electrode is directly proportional to quantity of current. Quantity of current involved in electrolysis process. This is called Faraday's first law. Faraday's first law. What is the Faraday's first law? The amount of substance deposited at the respective electrodes is directly proportional to quantity of current involved in electrolysis process. Okay, W directly proportional to Q. What is a W? Weight of the substance deposited or dissolved at a particular electrode. What is the Q? Quantity of current in coulomb. And to avoid proportionality, we use a proportionality constant, small e. What is a small e? Proportionality constant, or it is also called electrochemical equivalent. Electrochemical equivalent, commonly denoted by ECE, electrochemical equivalent. And what is Q? If 1 ampere current is passed through an electrical conductor in 1 second time, then that quantity is called 1 coulomb. Q is equal to C. Therefore, W is equal to EC. That is the mathematical form of first law of Faraday. Okay, if Q is equal to 1 coulomb, Q is equal to 1, then W is equal to E. What is E? Electrochemical equivalent. That is equal to weight of the substance deposited at a particular electrode. Therefore, E is defined as, what is E? Weight of the substance deposited by the passage of 1 coulomb current is called electrochemical equivalent. Electrochemical equivalent. Okay. If C is equal to 1 ampere and T is equal to 1 second in second equation. If C is equal to 1 ampere, T is equal to 1 second, then W is equal to E. What is W? The amount of substance deposited at a particular electrode. Therefore, electrochemical equivalent is also defined as weight of the substance deposited, weight of the substance deposited by the passage of weight of the substance deposited by the passage of 1 ampere current in 1 second time is called electrochemical equivalent. Okay, now. So what is electrochemical equivalent? weight of the substance deposited by the passage of 1 coulomb current, or weight of the substance deposited by the passage of 1 ampere current in 1 second time is called electrochemical equivalent. Okay. So what are the units of electrochemical equivalent? So what is the mathematical form of first law of Faraday? W is equal to EQ, or E is equal to W by Q. So in common system, weight is expressed in grams, charge is expressed in coulombs. So what are the units of electrochemical equivalent? Gram per coulomb. In CCS system, weight is expressed in grams, charge is expressed in ES. So what are the CCS units of electrochemical equivalent? Gram per coulomb. In SI system, weight is expressed in kilograms, charge is expressed in coulombs. So what is the SI unit of electrochemical equivalent? Kg per coulomb, Kg per coulomb. Okay, and what is the relation between equivalent weight, capital E, and electrochemical equivalent, small e? Capital E is equal to, electrochemical equivalent, small e, is equal to E by F. What is E? Equivalent weight. Equivalent weight is equal to atomic weight by valence. Atomic weight is denoted by valence denoted by Z into A. The relation between small e and capital. Therefore, what is the mathematical form of first law? W is equal to ECT. What is E? M by Z. M by Z into C. The mathematical form of Faraday first. Okay. So, దీంట్లో వాళ్ళు frequent గా ఇచ్చే questions. Electrochemical equivalent calculations. Generally, 1 Faraday means that is equal to 96,500 coulombs. అది ఎక్కడైనా 1 by Faraday కనిపిస్తే 1 by 96,500 coulombs కనిపిస్తే దాన్ని నియర్లీ 10 power minus 5 coulombs గా కన్సిడర్ చేయండి. అప్పుడు క్యాలిక్యులేషన్ ఈజీగా ఉంటుంది. 96,500 coulombs అంటే నియర్లీ 1 lakh. 1 lakh అంటే 10 power minus 5 coulombs. ఓకేనా? అండ్ నెక్స్ట్ వన్. Next one. What is the relation between quantity of current and weight of the element deposited at respective electrodes తీసుకున్నట్టయితే? First one, name of the element. Second one, gram atomic weight. Third one, valency. Fourth one, gram equivalent weight. Fifth one, equivalent volume. Equivalent volume. The next one, quantity of current. So most of the Faraday law related problems is just a tabular form idea ఉంటే చాలు. Name of the element hydrogen. Its gram atomic weight 1, valency 1, and equivalent weight 1. To deposit equivalent weight of a substance, 1 Faraday current is required. And 1 gram equivalent of hydrogen occupies 11.2 liters volume at SEP. And to deposit 1 gram of hydrogen or to liberate 11.2 liters of hydrogen, 1 Faraday current is required. Second one, oxygen. It's a gram atomic weight 16 grams. And its valency 2 gram equivalent weight, atomic weight by valence 8 grams. To deposit equivalent weight of a substance, 1 Faraday current is required. 8 grams of oxygen occupies 5.6 liters volume at STP. So what is its equivalent volume? 5.6 liters. And next one is chlorine. Its gram atomic weight 35.5 grams. Its valency 1. Gram equivalent weight 35.5 grams. To deposit equivalent weight of substance, 1 Faraday current is required. And 35.5 grams of chlorine occupies 11.2 liters volume at ST. Therefore, to deposit 35.5 grams of chlorine or to liberate 11.2 liters of chlorine, 1 Faraday current is required. And next element is sodium. Its gram atomic weight 23 grams. Valency 1. Therefore, its equivalent weight 23 grams. It is present in solid state. So volume nil. To deposit equivalent weight, 1 Faraday current is required. And next element is magnesium. Its gram atomic weight 24 grams. Valency 2. Therefore, its equivalent weight 12 grams. To deposit equivalent weight of magnesium, 1 Faraday current is required. Again, to deposit equivalent weight of sodium, 1 Faraday current is required. To deposit 12 grams of magnesium, 1 Faraday current is required. And next element is aluminium. Its gram atomic weight is 23 grams. Valency is 3. Its equivalent weight is gram equivalent weight 9 grams. To deposit equivalent weight, 1 Faraday current is required. Next element is copper. Its gram atomic weight is 63.5 grams. Its valency 2. So to deposit equivalent weight of copper, 1 Faraday current is required. And next one is zinc. Its gram atomic weight is 65.3 grams. Its valency 2. To deposit equivalent weight of zinc, 1 Faraday current is required. Next one is silver. Its gram atomic weight 108 grams. Valency 1. Equivalent weight 108 grams. To deposit equivalent weight of silver, 1 Faraday current is required. So these are the elements which are frequently asked in EAMCET, PS and AP states. So if we are familiar or thorough with these numerical values, we can easily calculate numericals based on Faraday laws. Numericals based on Faraday laws. Okay, ma'am. And suppose consider electrolysis of sodium ions. To deposit or to discharge or to reduce one sodium ion, one electron is required. To reduce 1 mole of sodium ions, 1 mole of electrons are required. What is the charge of 1 mole of electrons? 1 Faraday. Ante to deposit or reduce 1 mole of sodium ions, how much current is required? 1 Faraday. See another example. Mg plus 2 ion. To reduce this Mg plus 2 ion, 2 electrons are required. To reduce 1 mole of magnesium ions, how many moles of electrons are required? 2 moles of electrons are required. 2 moles of electrons means how many Faraday's current is required? 2 Faraday's current is required. So what is the charge present on magnesium ion? 2 units positive charge. 1 unit of positive charge requires 1 Faraday. 2 units of positive charge requires 2 Faradays. Let us consider another example. Aluminium. To reduce 1 aluminium ion, 3 electrons are required. It reduces Al plus 3 into Al. To reduce 1 mole of aluminium ions, how many moles of electrons are required? 3 moles. And deposits 1 mole of aluminium. What is the charge of 3 moles of electrons? 3 Farads. So that is equal to charge present on the ionic. Therefore, the quantity of current required to reduce 1 mole of M plus N ions is equal to N Faradays. So the ఇష్టమొచ్చిన ion this 1 mole of ions ని discharge చేయాలంటే quantity of current is equal to charge present on the ion. Suppose to reduce 1 mole of Cu plus 2 ions, how many Faradays required? That is equal charge present on ion. To reduce 1 mole of zinc ions, how much current is required? 2 Faradays. To reduce 1 mole of Ag plus ions, how much current is required? 1 Faraday. To reduce 1 mole of Sn plus 4 ions, how much current is required? 4 Faradays. To reduce 1 mole of Ba plus 2 ion, how much current is required? 2 Faradays. Okay. See the formula to calculate quantity of current required to reduce 1 mole of M plus I electrons. So very important model. See question వాడు frequent గా అడుగుతా ఉంటాడు. So జాగ్రత్తగా గుర్తుపెట్టుకోండి. In next class I will explain Faraday's second law and Faraday's second law related problems. Thank you. Thank you very much. So time over.